Okay, so this homework was ridiculously easy. It's finding the slope, but I did promise that I would do every single problem that I assigned, so here we go. In order to find the slope, you need to know the slope formula. And that would be m equals y2 minus y1 over x2 minus x1. And I use these different colors, so you could always start with the division bar and the subtraction symbols, and then you plug in your x and y's from your coordinates. Now remember, your coordinates are x and y values. But in order for you to know which x I'm talking about, we're going to label the first x x1 and the first y y1, and then the second x x2 and the second y y2. And now you're able to identify which is y2 and which is y1, and so on and so on. So if you don't know the formula, if you don't have this memorized already, please write it down on every problem until you have it memorized. Once you have it memorized, then you could just jump right into the division bar, the subtractions, and then plugging in your values. 2, y1 is -8, x2 is -5, x1 is 3. Change the minus minus to plus plus. You end up with 10 divided by -8. And you can't divide 10 by -8, but you could reduce it. And let's put that negative either above or right in front of the fraction. Don't leave it in the denominator. 10 divided by 2 is 5. 8 divided by 2 is 4. So we reduced by 2, and it gave us -5/4. So that's your final slope right there for number 1. Let's move on. Number 2. I'm going to speed things up a bit. I'm not going to explain them all as thoroughly as the other one. So here's the formula. And again, we're going to plug in our values by first starting with the division and the subtractions, and then we're plugging in our x, y, and our x and our y, and this is our first point, and the second one is right there. So y2 is 2, y1 is -3, x2 is 7, x1 is -10. Change the minus minus to plus plus on both situations, or both numerator and denominator. 2 plus 3 is 5 on top, and 7 plus 10 is 17 on the bottom. That's your slope. You can't reduce it. You're done. That's number 2. Let's move on. Number 3. So here's our formula again. Let's label everything. X, y, first point, x, y from our second point. Use the division first, the subtraction symbols, then plug in. y2 is -6, y1 is -6, x2 is 3, x1 is -7. Change the minus minus to plus plus. On top, -6 plus 6 is 0. 0 divided by 10 is 0 divided by anything is 0. So the slope is 0. That's number 3. If you were to graph it, it'd be a totally flat line. It's not steep at all. It's the opposite. It's steep, totally flat like the floor. Moving on to number 4. Here we go. All right, so we needed the formula. There it is. Let's start it up again. So division, subtraction, label x, y from your first point, x, y from your second point. y2 minus y1 equals or over x2 minus x1. So we end up with -1 minus 2, that's -3. And 8 take away 8 is 0 on the bottom. Now remember, if 0 is underneath, it's undefined. Undefined. The slope is undefined. Okay? Underneath, undefined. Undi, okay? M equals undefined. All right, so when 0 is on top, the answer is 0. When 0 is underneath, it's undefined. Let's move on to number 5. So I don't expect you to write the formula every single time. I mean, once you got it down, then you just jump right into it, right? Division, subtractions, and it's y2, which is -2, minus y1, which is 3, over x2, which is 7, minus x1, which is 4. So if this is confusing to you, make sure you write the formula, you label the coordinates, your x1, y1, x2, y2. Up on top, -2 take away 3, that's -5. On the bottom, 7 take away 4 is 3. And that's your slope. So m equals -5/3. That's your slope for number 5. Let's try number 6. I'm just going to go with the formula one more time. There it is. And of course, x, y, first point, x, y, second point. And let's plug it in. Do the division first, the division bar first, and the subtraction symbols, and then plug in your 4, which is a y2, your -3, which is a y1, your -8, which is a x2, x1 is -6. Change the minus minus to plus plus. You're going to end up with 7 over -2, and that's all you could do. M equals -7 over 2. Let's move on, number 7. Finally, we get to visuals. I like visuals. They're super easy. All you got to do is find 2 nice points. Now, what do I mean by nice points? You don't want decimals, you don't want fractions. Like, for example, the coordinate 0, 0, that's a nice point. Or 0, -1. Or -1, -1, that's a nice point for x and y. But when you get to like this coordinate right here, that coordinate's like -2 for the x and -1, -1 and 5/8 or -1.65 or something like that. This is not a nice point, right? Because you end up with a fraction or a decimal location. So look at your line and find nice coordinates. Here's a nice coordinate. Let's put a dot right there. Let's continue looking at this line from left to right. That's not a nice point. That's not a nice point. That's a nice point right there. This is not a nice point. This is a nice one, so let's put it right there. And now we could look at these 2 dots and decide whether we're rising from left to right or we're dropping. And we're obviously going down from left to right, which means that it's a negative rise. How much do you drop? How many units from here to here? You go down 1 unit. And how many do you run? 1, 2, 3. So the slope is, we said down 1 over 3. That's your slope for number 7. Let's move on. Number 8. It's all about finding those nice points, so nice clean points. This is not a nice point. This is a nice point. Let's put a dot right there. Let's continue on. Not a nice point. Not a nice point. Nope. Nope. Yep. Right at the origin. That's a nice one. Now we could actually count our rise and our run. So it's up 1, +1 for the rise, 1, 2, 3, 4, 5 for the run. So the slope is +1 over +5. That's our slope. Almost done. So let's find our nice points. This is actually a nice point. That's actually a nice point. This is actually a nice point. This is actually a nice point. You could use any points you want, right? Any points you want. So I would use just 2 points that are right next to each other, like right here and right here. Or from right here to right here. Or if you wanted to, you could go from here all the way up here. No, it doesn't make a difference. You're still going to end up with the same slope. Let me explain here. So if we look at, let's say, this one, this green one, and that green one. What's your rise and what's your run? Your rise is 1, and your run is also 1. So it's really the slope 1 over 1. Okay. So if I say my slope is 1 over 1, that is correct. Now, what if you use the blue ones? Well, the blue ones, you'd go up 1, 2, 3, 4, 5, 6, and you'd have to run 1, 2, 3, 4, 5, 6. So using the blue ones, I'd have the slope 6 over 6, which also reduces down to 1 over 1. So you could use any points you want as long as they're nice points, right? And also as long as you reduce whenever you can. Always reduce fractions that you can reduce. Let's move on to number 10. Picking 2 nice points. There's one, there's another. What's happening from left to right? It's dropping. How many levels does it drop from the point that we selected to the other point? It drops 1 level and it goes over 1 level. So it's down 1 over 1. So the slope is -1 over 1. Of course, in the back, I believe they just write it as -1. But I like seeing the fraction since we visually see that it drops 1 and it goes over 1. Number 11. Let's find 2 nice points. That's not a nice point. This is not a nice point. This looks like a nice point. Let's put a dot right there. Let's find another one. Continuing, that's a fraction, decimal fraction, right? Like there's the next nice point right there. And the slope is, what is my rise? Well, I'm not rising. I'm actually dropping from left to right. So I'm dropping 1 unit, 2 units, 3 units, 4 units, 5 units. 5 down over 1. So dropping 5 would mean -5. Running 1 is +1. The run, we're always looking at it in a positive sense, always from left to right. So that's my slope. Of course, you could write it as slope being -5, but I prefer -5 over 1. Last one here. Let's find some coordinates that work good. There it is. That's a good one. Let's put a dot right there. Continuing. Not good, not good, not good. That one, I'm not sure if that's pretty. Let's see. I don't think that's good. It looks like the line's slightly off of that intersection right there. It looks like it's a little bit this way. Just like this one, it looks like it's a little bit that way. So let's find an intersection that's even. There you go. This looks like it's the best intersection. I'm assuming. I mean, I could be wrong, but let's find out. Let's compare those two red dots that we put. This one up here with that one down there, and this one rises 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2. So 9 over 2. The slope should be positive 9 over 2 on number 12. Okay, I finished this homework. It was ridiculously easy, but I kept my promise that I explained every single problem that I assigned.